In my previous video I looked at transaction ID locking, which is one of two parts in the optimized locking feature. Let's look at the other part of optimized locking, which is called Lock After Qualification. And to understand why Microsoft built this, let's instantly jump into a demo to see what problem there was and is fixed by this feature. So let's make sure that we set up the database, and as you see, I'm already switching accelerated database recovery on and read committed snapshot on, because those are requirements for later. What I then do is I create a products table and I put some data in there. Nothing special. Let's make sure that optimized locking is off. So now I'm going to show how things worked until SQL Server 2022 and on SQL Server 2025, as long as you don't enable optimized locking. For this demo, I'm going to start a transaction and then increase the purchase price of all products that are below $10 from manufacturer 1. Now, this normally should be in a transaction that hopefully completes fairly fast, but sometimes transactions last a bit longer. For instance, in a demo when I begin a transaction and I never complete it. That allows me to look at the logs. And of course, without optimized locking, we get the expected exclusive lock on a specific key, which represents one row. Now the nice thing is that because we have read committed snapshot isolation, readers are not blocked by writers. That means I can still see the data. I see the old version of the data. The new version is not committed yet. It might eventually be rolled back and then it would never officially have been correct data, so we definitely should never see that data. And indeed, recommitted snapshot isolation doesn't wait for the log to be released, it simply returns the last committed data, and that means that we can also see that only this row is affected by the update. All other rows are either for a different manufacturer or above $10. So this first row is blocked, the rest is not. Now, if I want to modify data for manufacturer 2, that would be product IDs 2 and 4. That's different product ID, and you might hope that this transaction is not blocked. But as you see, it is. And let's see what we are waiting for by moving back to a transaction that is not blocked. And what was the number? It was 70. Let's look at what logs are held by the blocked session. And now, if I scroll a bit to the right, you see that there's one waiting log. Scroll back left again. That is a key log. And we want a U log, which means read this data, but I might want to convert it into an exclusive log later. Why is this session requesting a key log on a key that is blocked? We know that the only blocked row doesn't even qualify. So to understand this, let's cancel the update and look at the execution plan. Now, in the execution plan, you will see that there is a clustered index scan. And this clustered index scan then tests the rows, but after reading all the rows. So at this point I can talk about what the problem is, because we are reading a row to update. But we need to find the rows to update, and when we do that we come across rows that do not qualify, but they are blocked. And we can't read them because they are locked. In this case we used a U log. Even if it had been an S log, a shared log, that would also have been blocked by the existing exclusive log on the row. We use a U log to prevent deadlock scenarios, but honestly it would have been the same anyway. So that is why this transaction, let's execute it again, still is waiting until we finally commit or roll back this transaction, and after this has been rolled back, the update finishes. Let's roll this back too. And let's now talk about the solution. But before that, I forgot to say that. Let's jump back into the demo. Let's look back at the execution plan again. What you see, like I said, is a clustered index scan. You might have preferred a clustered index seek on an index on the manufacturer ID column. And yes, in this case, that would have helped. We would never have tried to read the row that is blocked, and the update would have executed. And of course, if you frequently run updates like this, an index on manufacturer ID would be helpful. But in reality, you have to realize that we very often run updates with where clauses that are one of a kind, unique. It's not always the same. Sometimes we have a weird update where someone writes the where clause, and it's something we've never done before. We will never do it again. There's probably no index to support it. So while indeed ideally indexing would prevent this, the world is not ideal. This scenario happens, and that is why Microsoft decided to build Lock After Qualification as a new feature in SQL Server 2025. Now, Lock After Qualification is part of optimized logging, so you need to turn on optimized logging, which means, as I talked about in the previous video, that you need to have accelerated database recovery turned on, which enables the persistent version store. It is not possible to enable a Lock After Qualification without transaction ID logging. As soon as optimized database logging is on, transaction ID logging starts, whether you want it or not. Frankly, most of the time you will want it, so it's not a bad thing, but you need to be aware of this. If you want Lock After Qualification, you do get transaction ID logging. The reverse is not the case. Just turning optimized logging on will give you transaction ID logging, but for Lock After Qualification you also need the database to use read committed snapshot isolation. So if you don't have read committed snapshot isolation, you would get transaction ID logging but not Lock After Qualification. With optimized logging and read committed snapshot isolation turned on, you get transaction ID logging and Lock After Qualification. So what happens if you do this is that now we have read committed snapshot isolation. SQL Server will read the row without locking it first. And then if the row qualifies, it will try to upgrade to an exclusive lock so that it can modify the data. So let's return to our demo. Make sure that, we were already rolled back. So let's now enable optimized logging and then run the same demo. So back to the top, we begin a transaction, we update effectively only product ID 1. And now we want to do an update to products that we know are products ID 2 and 4. And look, I can just update them. Because when SQL Server was reading the data, it did see this row, but it used snapshot isolation to get this old row. It saw that it was manufacturer ID 1. It doesn't qualify. It reads on. It goes to this row. That row had to be modified. And that takes an exclusive lock, but an exclusive lock on this row does not conflict with the exclusive lock we have on the other row. Now, if we were not discontinuing manufacturer 2 but manufacturer 1, then let's look at the data again. SQL Server would try to discontinue this row. It reads it, it sees it does qualify, and now it tries to upgrade the lock to exclusive, and this is where the process still halts. Updates to the same row are still blocking each other, as they should, of course, because we don't want to overwrite the modifications from another transaction. That would be bad. So that is how this feature works, and you see that this helps performance in cases where, due to missing indexes, updates have to read past rows that don't qualify and then can get blocked by those rows, those cases are now fixed by Lock After Qualification. So, like I showed in the demo, if there are locks on rows that are not will not qualify, then even though we do read them in the update statement, we don't have to wait for that lock to be released. If there is a lock on a row that does qualify, then we still have to wait as we should. Now, of course, everything always comes at a price. And I already said, Lock After Qualification cannot be enabled without transaction ID locking, so we need the persistent version store. Even though it's not used for this feature, it's used for transaction ID locking, and that means you get the persistent version store, which will increase the size of your database. I talked about that in the previous video. And you get read committed snapshot isolation, which might be a benefit. But if your application was never tested with read committed snapshot isolation, then this might cause things that you didn't expect, perhaps even bugs. Some certain scenarios where multiple transactions happen at the same time behave different under read committed snapshot as compared to regular read committed. And yeah, that might be a benefit because readers and writers don't block each other anymore, but it might also be a problem because those readers now return old data instead of waiting and then returning new data. And if your application is not built for that and is not tested for that, you might run into issues, and issues that are hard to predict in testing because they are basically race scenarios. Then also specifically to updates, I can show that just switching on Lock After Qualification can affect the outcome of certain race conditions. So let's move back to the demo and let's move to this window. So I'm first going to switch optimized locking off again, and once that is done, I'm going to put the original data back in the table. And now what I do is a different change. So product 2 happens to be a bit cheaper with manufacturer 1. So to save $1, we're going to change our manufacturer, our purchase information. We don't buy it for $200 from manufacturer ID 2, but for $199 from manufacturer ID 1. That update has now executed, but not committed yet. At the roughly the same time, while this update is still active, another employer got a message that manufacturer 1 just went out of business. So all products we purchase from manufacturer 1 need to be discontinued. And that is of course this update, which is blocked. Without Lock After Qualification, this is still blocked because we still don't have an index on manufacturer ID. Every locked row in the products table will block this. So this waits. Of course, in a real system, that will be just a few milliseconds. Transactions are always short. This is a race condition. They happen to be at almost the same time. Now, this other transaction is also committed, and as you see, this now ends. Both updates have now executed, they have been committed. And what is the effect? Product ID 2 was switched to manufacturer ID 1 just before they went out of business. Then they went out of business, and now product ID 2 is discontinued. Commercially speaking, not optimal, but the logical consequence of the order in which the modifications were made. We first switched product ID 2 to manufacturer 1, and then manufacturer 1 went out of business. Now, how would optimized locking and specifically Lock After Qualification affect this scenario? Let's enable optimized locking, and let's then run the same scenario again. So I'm going to put back in the original data, and then I'm going to do the same thing. We switch to a different manufacturer for product ID 2. this transaction has not been completed yet, lock after qualification now enables this modification to just complete. There is no problem, this has been committed. And again, in a scenario where it's a race condition between transactions that last just milliseconds, you might not even notice that this transaction commits a bit later. But now in the results you see something weird. You see that product ID 2 has been updated to manufacturer ID 1, which is the first update we did, but it wasn't committed yet when we discontinued manufacturer 1. Product ID 2 was not committed yet, so this transaction still saw the old version of the row with manufacturer ID 2. That didn't qualify, so we didn't update it. This was committed, then this was committed, and now the effect is that one of the products from manufacturer ID 1 is not discontinued. Probably this is not what you intended. This might be an incorrect result. Also, what happens is not really consistent. Here, this product was not discontinued based on the manufacturer ID from before the update. But let's make a slight modification and run the same scenario yet another time. So put it back in the original data, change product ID 2, and now it's not manufacturer 1 that went out of business, but manufacturer 2. And this is blocked. Why is this blocked? Because once more, lock after qualification reads the original row from the products table. So for product ID 2, it still reads manufacturer ID 2. This update has not been committed yet, so it doesn't see it. So it wants to update this row. It tries to lock the row, and it can't. Okay. But that is in this case desired because they are conflicting updates. So let's commit the transaction, and now this transaction finishes too. And let's now look at the effect. And where you might have expected the same inconsistency as, well, the reverse inconsistency as before, where you might have expected product ID 2 to be discontinued, because, like I said, this update saw the row and wanted to update it, but it isn't. The reason is that, yes, this update read the old version of the row. It said, hey, I want to update it. It waited. We committed this transaction. This row continued, but instead of blindly updating, lock after qualification is actually smart enough to look at the data again and see that, oh, the row that did qualify just before now no longer qualifies and it is not updated. Which actually gives a better end result, but it also results in a rather weird scenario where in some cases this row is skipped because the old information didn't qualify even though the new information doesn't. And in other cases it is skipped because the old information did qualify, but the new information didn't. So if we change a row from qualifying to non-qualifying, it will not be updated. If it changes from non-qualifying to qualifying, it will also not be updated. The only rows that are updated if you have lock after qualification turned on are rows that qualify both with their old committed version when there is something locked, and then after the lock has been released, they still need to qualify. Only those rows will actually be updated. And that, again, might not be what your application expects. Applications are usually built with the expectancy of a certain type of handling of race conditions, and this changes the race conditions. So the price for lock after qualification is that you really need to look hard at all possible race conditions in your application, and you might need to test for problems there. Anyway, I must say I still like the feature. The number of cases where it actually kicks in is probably not very high. Most real-world applications use updates based on a user screen that simply have the primary key, and that means it's always indexed data and we never have this problem. But in those cases where there are other updates and where you can't use the perfect index, you might run into this problem, and Lock After Qualification neatly solves this if you can work around the possible changes to race conditions. Overall, I think I like the feature. Even though its application is a bit limited, it still is a nice to have. That concludes this video. If you want to like or subscribe or leave a comment, I'm always happy. And of course, if you want to hire me to fix your slow performing servers, let me know and we can talk. Thanks. Bye bye.